8.2, Analyzing Arithmetic Sequence and Series on page 418 through 421 in your textbook. An arithmetic sequence is the difference of consecutive numbers is constant. So when we talk about difference, we're talking about adding and subtracting numbers, and constant meaning them being the same. This is representative of a linear function. Alright, concept 1, identifying arithmetic sequence. So tell whether each sequence is arithmetic. 1a, the difference between negative 9 to negative 2 is 7, or how do I get from negative 2 to 5? I add 7, 5 to 12, I add 7, 12 to 19, I add 7. So my common difference is 7. That's where the d equals 7 there, and this is an arithmetic sequence. As opposed to b, where how do I get from 23 to 15? I subtract 8. How do I get from 15 to 9? I subtract 6. 9 to 5, I subtract 4. Well, those are not common, therefore it's not an arithmetic sequence. You're going to do the same thing here with number 2. Tell whether the sequence is arithmetic or not. And go ahead and pause it. I'm going to show this answer. There we go. 1a is not an arithmetic sequence. 2b is, yes, the common difference is negative 3. It's an arithmetic sequence. Alright, next. Rule for arithmetic sequence is this right here. A sub n equals a sub 1 plus the quantity n minus 1 times d. A sub 1 being the first term, alright, and d being that common difference. Alright, so what we're going to do is write a rule for the nth term. And let's just do it right here. Okay, so first things first. I could say, how do I get from 3 to 8? I add 5. 8 to 13, I add 5. 13 to 18, I add 5. My common difference is 5. Also, my first term right there, a sub 1 is 3. And if I have those two things, I can plug it into that formula right there. So a sub n equals a sub 1, which is 3, plus the quantity n minus 1 times d, which is 5. What you're going to do is distribute that 5 on in, the quantity of n minus 1. And you get 3 plus 5n minus 5 is a sub n. And therefore a sub n is equal to what? Well, 5n minus 2. And voila, we have our rule. Next, what we're going to do is find the 15th term. So when you do something like this, you can find any term with the rule. Once you have the rule, you can find the 12th term, the 120th term, 15th term, whatever. All you're going to do is substitute 15 in for n. So a sub 15 equals 5 times 15 minus 2. And that is 75 minus 2, and that is 73. So a sub 15 is 73, and done. I got my 15th term. Really similar over here, do the exact same thing. This time, how do I get from 55 to 47? I subtract 8, 47 to 39, I subtract 8. My common difference is negative 8. My first term, a sub 1, is 55. Again, I'm going to plug it right here into this formula. A sub n equals a sub 1, 55, plus quantity n minus 1 times my common difference. This time it's negative 8. Distribute negative 8 into the quantity of n minus 1. You get 55 minus 8n plus 8. A sub n equals negative 8n and then plus 63, and there is our rule. Alright, now if I want to find the 15th term, I think I can do it right here. A sub 15 equals negative 8 times 15 plus 63. A sub 15 equals negative 120 plus 63. A sub 15 equals negative 57. And done. Alright. Go ahead and try number 4. I'm going to show the answer here, so pause it up. the answer to number 4 is right there. A sub n equals 3n plus 4 is the rule for A, and A sub 15 is 49 for B. A sub n equals negative 7n plus 22, and the 15th term is negative 83, sorry. Alright, very good. Once you got it, flip it on up. Page 6, I'm just going to go ahead and show the graphing one here. Alright, so what we're doing here in this one is writing a rule for a given term and a common difference. This time that given term, though, is the 19th term. Our common difference is negative 3. So what we have to do is use our equation right there, our rule. And if I plug in a sub 19, I substitute 19 for n, I get that 19th term. And I get a sub 1 plus 19 minus 1. Right, I substitute 19 for n in both of those. Then I get 19 minus 1 is 18. So then if I substitute negative 45 in for a sub 19 and negative 3 in for my common difference, now all I have is a sub 1 to solve for. So I get negative 45 equals a sub 1 minus 54. Add 54 to both sides, I get a sub 1 is 9. And if I have my first term, a sub 1, and my common difference, then I can write the rule. Plug in a sub 1, put my common difference in that quantity of a sub n equals 9 plus the quantity n minus 1 times negative 3. Distribute that negative 3, combine like terms, and you get a sub n equals negative 3n plus 12. Now my first term is 9, which we knew already. And the second term I can either plug in, so I put 2 in there, I get negative 6 plus 12 is positive 6. Or just do 9 minus 3, right? My common difference is 3. 6 minus 3 is 3. 3 minus 3 is 0. 0 minus 3 is negative 3. Negative 3 minus 3 is negative 6. When you plot your points, your order pairs right there, you do not draw a line because it's just an arithmetic sequence here, so it's just those points. It should look and represent a linear function. Give number 6 a try. I'm going to go ahead and show the answer here. I only went the first 5 terms since that 6th term's not even on the graph, so you guys can just go that first 5 terms as well. And again, pause it up so you can work out that problem. I'm showing the answer now. Okay, so when you go ahead and solve there, you get a sub n equals 6n minus 20. And then my first term's negative 14, negative 8, negative 2, 4, and 10. And there is my graph right there. Alright. Next, I'm going to go ahead and do number 7 here. So I'm going to put this over here. Alright, so this time we have 2 terms in an arithmetic sequence of a sub 7 equals 17 and a sub 26 equals 93. I'm going to write a rule for the nth term, so I need my first term and my common difference. Okay, so I kind of go about it like this. It is more of like a systems of equations since we're solving 2 unknowns here. So a sub 26 equals a sub 1 plus the quantity of 26 minus 1 times d equals 93. Okay, and then I can get rid of that a sub 26. I'm going to do the same thing here with a sub 7 equals a sub 1 plus 7 minus 1 times d equals 17. Alright, so I'm just going to simplify across here, or take out that part, so I get a sub 1 plus 25d equals 93. I'll do the same here. Take out that a sub 7, so I get a sub 1 plus 60 equals 17. Just simplified what was there. Now I have something that looks more like a systems of equations. And if I eliminate by subtracting, I subtract all my terms, change all your signs to the opposite, and then a sub 1 cancels out, right? And now I just have d all by itself. So 25d minus 6d is 19d. And 93 minus 17 is 76. Divide by 19 to both sides. And d is equal to 4. And there's my first unknown I solved for. And if I plug it right there, right, if I put the 4 right there for d, then I can solve for a sub 1. sub 1 plus 25 times 4 equals 93. A sub 1 plus 100 equals 93. Subtract 100 from both sides. A sub n equals -7. And now if I get both those, a sub 1 and d, I plug it back into that initial formula. I'll write it here. A sub 1 equals a sub n equals a sub 1 plus declining n minus 1 times d. A sub n equals -7 plus declining n minus 1 times 4. Distribute. -7 plus 4n minus 4. And now I get 4n minus 11. A sub n equals 4n minus 11 is the rule.
Special announcement. We have CAP makeup testing going on.
Flip the page and give number 8 a try. Pause it up because I am just going to go ahead and show this answer.
And you know you have to make up the CAP. Please go to WL6. That's World Language 6. And teachers, look out for an email for students to send.
Here's the answer to number 8. A sub n equals 5n minus 68. And I'm going to go on to this last problem here. What we're going to do is find the sum of a finite arithmetic sequence. And here, S of n equals n times quantity a sub 1 plus a sub n over 2. N is the number of terms. A sub 1 is the first term. A sub n is the last term over 2. So I'm just going to go ahead and show this one. So if you look here, our upper limit's 20, our lower limit's 1. Our rule is 3i plus 7. A sub 1 will give us our first term, which is 3 times 1 plus 7 is 10. A sub 20 will give us our last term. So 3 times 20 plus 7 is 67. So the sum of the 20 terms is 20 times the quantity of 10 plus 67 divided by 2. I cross-canceled. 20 divided by 2 is 10. 10 times 10 plus 77 is 77. So I get 770. The sum of the 20 terms in the arithmetic sequence is 770. So a series, again, you guys, is the sum of all the terms. Alright, guys. Here we go. Last problem. Go ahead and pause. Give it a try. I'm going to show your solution right now. Last problem. The sum of the 18 terms is 990 for number 10.